In this video, I will be going over lesson 1, which is about combining like terms. All right, so first, let's talk about some definitions that we need to know. Okay, first is a variable. So a variable is a letter that represents an unknown number. So we could see here that anytime you have a number that is attached to a variable, okay, these are going to be our variables. So variables are always going to be our letters when we see them in an expression. The next term is going to be a coefficient, and a coefficient is talking about the number that's in front of your variable. So I could see here I have an A and a B, and then this 2, this 3, and this 8, sorry. Those are my coefficients. They are in front of my variables. Okay, so variables and coefficients are sometimes next to each other. And coefficient is going to be the number. Variable is going to be the letter. The next definition is a term, okay? And a term can be a number, it could be a variable, it could be a number attached to a variable, all right? So here, this whole piece right here, this whole unit, this pair, that is one of my terms. The next one, this 3a, that is also a term. This next one here, 8b, that is also a term. And then this 17 all the way at the end. However, even though there's no variable that's attached to it, it is still a term. Okay, and you can notice that our terms are being separated by these plus and minus signs. Okay, so those plus and minus signs that we're going to see in our problems are separating our terms. And then the very last one that we're going to hear, that you'll probably hear this one more so than others, is like terms. And like terms are two or more terms that have the same variable attached to it. So when I look at my expression here, the 2 and the 3, both of those have an A attached to it, right? So because they have that A attached to it, that makes them like terms, okay? So anytime you're looking at an expression and you see variables that have the same letter, okay, those are going to be your like terms. And if you remember, this entire lesson is going to be about combining those like terms. So being able to identify which numbers have the same variables attached to them, and then that's going to be our first step when we're combining like terms. Okay, so when you're combining your like terms, the sign in front of your term is always going to be attached to it. Okay, so here's that same example that we were working with on that previous slide. And I can see that there's a total of 4 terms here, right? I have 1, 2, 3, 4 total terms. So there's 4 of them. What I like to do when I'm solving these is I like to put a little slash to the left of my plus or minus sign, because that reminds me that that plus sign in front of the 3 here is attached to it. And this minus sign in front of this B is attached to it. And what this does is it helps us solve these problems, because we have to know whether or not we're adding or we're subtracting. So putting those slashes helps us kind of remember that. And when we do more examples, it'll become more familiar to you. So we have identified which terms are like terms, right? We did that before, which is this 2a and this 3a, because they have the same variable. Okay, remember, like terms must have the same exact variable. Once we have determined that those are our like terms, all I need to do to combine them is add my numbers together, and I keep my variable the same. Okay, so I have this 2a and I'm adding it to 3a. So to solve this, I have to go, well, what is 2 plus 3? 2 plus 3 gives me 5, and I keep my variable here. Okay. Another way to think of this is like this, okay? When I have two A's, that's like me having A, right? There are my two A's, and I'm adding it to, and then on this left side here, I have three A's. So I have A, and A. So my answer is going to be, well, how many A's do I have written? I have 1, 2, 3, 4, 5 total A's, okay? So that is another way of representing what's happening here. So once we have combined our terms, which is where we're adding those whole numbers, the 2 and the 3, which is how we get our 5. Don't forget to keep your variable. That's huge. Don't leave it. It still wants to be next to its number. Then all I do is I'm going to leave everything else in my expression the same. This 8b and this 17, those aren't going anywhere, right? They're still a part of our expression. We just can't combine them with anything because none of them are like terms, right? I have an A, a B, and then just a number. None of those are the same, so I cannot combine them together, which means that this here would be our final answer. Okay, so this 5a minus 8b plus 17, that is going to be our final answer. All right, so let's do another example. So we want to simplify the expression by combining our like terms. So first of all, let's kind of look and see, well, do I have any variables that are the same? And when I look here, I see a 4x, I see a 13x, and I see a 9y. So right off the bat, I'm going, well, this has an x and this has an x. So those two are going to be my like terms. So remember, I'm going to draw my slashes in front of my plus and minus signs. Okay, so I need to combine these two together. So I'm going to have a 4x, and then this plus 13x is going to come with it. Okay, so now let's combine these together. So if I have 4 x's and I'm adding them to 13 x's, remember I can add my whole numbers. So 4 plus 13 is going to give me 17. And then I can't forget my variable x. Okay, so that means that this first part that I have circled here simplifies to 17x. And then I can't forget that last part of my expression. And the last part of my expression is going to be this whole piece here. So this whole minus 9y. You could see that this slash here, right, it kind of separates it. And this minus 9y, we're going to move it as one unit at the very end here. Okay, so my final answer here would be 17x minus 9y. All right, let's do another one. So let's identify our like terms by checking the variables to see if any of the variables match. All right, I have 13y, 5x, 10x, and 7y. So let's start by identifying my terms. So here I have 4 terms, right? Here we go. I have my 4 terms. And I have 13y, and then a 7y. And then I see here I have a 5x and a 10x. So here I have two different sets of terms that I can combine, right? I have y's that I can combine, and I also have x's that I can combine, okay? So let's do those separately. Let's start with our y's. So my first is 13y. And then here I have this 7y, okay? And notice how this minus sign is a part of my 7y term. Okay, this is why I draw those slashes so that way I know what sign is moving with my number. Okay, since this minus sign is in front of my 7y, it's going to move down with it, and I'm going to be subtracting here. Okay, so 13, I'm going to be doing 13 minus 7. So 13 minus 7 is going to be 6. And then I can't forget my variable, which is y. So 13y minus 7y is going to give me 6y. All right, let's do our next one, which is going to be 5x. Right, I have a plus 5x, and then my next is minus 10x. So here is where we have to be careful, and this is where if you wanted to double check this in a calculator, I would not judge you. In fact, I would encourage it. A lot of the mistakes that I see on these problems are forgetting the correct sign. Okay, right here we see 5 minus 10, and you might be going, well, that's 5, right? However, remember that with subtraction, your order matters. So since my smaller number is first here, when I do 5 minus 10, this is actually going to give me a negative 5. Okay, if I were to draw a number line, and here is 5, I need to move back 10 spaces. So I'm going back 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to end up right here. 0 is right here. And all the way back here, because I'm going past 0, is negative 5. Okay? So just double check our signs on these, because that's where I see the most mistakes, which is where having a calculator is handy because I can very easily type that in. Okay, so I have my two different terms. I cannot combine these because my variables are different. Okay, I cannot do 6y minus 5y or 5x because those variables are not the same, which means they're not like terms. So to write my final answer, all I need to do is write them next to each other. So I have my 6y minus 5x, and that's going to be my final answer. All right. Let's do one more. This one is a bit of a longer example, but we'll probably see some of these in our workbooks and our checkpoints. Okay, so to simplify this expression, again, I'm going to start by separating all of my terms, okay, with my slash marks. And when I'm looking at this, I see a lot of x's, and then I also see just regular numbers, right? There's that negative 10 and then that 7. Now, since there's no variable attached to those, and they're just regular old numbers, those are actually like terms. Okay, so my first set of like terms that I can combine are going to be this minus 10 and that plus 7. So I'm going to pull those down to add them together. So I have minus 10 plus 7. Now negative 10 plus 7, again, feel free to type this into a calculator to double check. You should get negative 3. All right, let's do our next one, which is going to be all of these x's here. Okay, those are going to be all my other like terms. Because they all have the same variable, I can add them all together. Don't forget that whatever sign is in front of your term is moving with it. So I'm starting with a positive 3x. My next is going to be minus x, followed by minus 7x, followed by a plus 5x, and very last is plus 2x. Okay, so to make this a little bit easier, I'm going to kind of do this piece by piece. Okay, now right here I have a variable and it's just x. There's no number in front of it. However, anytime I or you see a variable with just the variable, there's no number attached to it, there is always going to be an invisible 1 in front. Okay, and if you think about it, your variable just represents a number that we don't know, all right? But anything times 1 is going to be itself, right? 8 times 1 is 8. 9 times 1 is 9. 250 times 1 is 250, which is why we can put that 1 in front of the variable. Okay, so from here, all we're going to be doing is subtracting and adding these numbers. So what I essentially have here is 3 minus 1, minus 7, plus 5, plus 2. Okay, and then I can't forget to bring my x onto my final number. And if you wanted to, you can type this into your calculator to double check it. That's 100% okay. I would encourage that to double check your answer anyway to make sure that your sign is correct. So 3 minus 1, this is going to give me 2. Minus 7 is going to be negative 5. Negative 5 plus 5 is 0. 0 plus 2 is 2. So here I get 2x. Okay, so when I add all of these and subtract them all together, I get a 2, and then don't forget to bring your x next to it. So our final step here is going to be writing these next to each other, so negative 3 and 2x. You can write this as negative 3 plus 2x, and the reason why there's a plus sign here is because this 2 is positive, right? It is a positive 2, so that's why I have a plus sign here. If you wanted to, you can also write them in reverse. I could do 2x first, and then I could write my minus 3 afterwards. Both of those are the same. Okay, they're going to give you the same answer. So whichever way you prefer. Okay. So sometimes we'll see some expressions that have decimals, and we're going to solve these the same exact way that we would the other ones, except instead of having whole numbers, we're just going to be dealing with decimals. And the thought process here is the exact same. And remember that we have that calculator to help us with our math with those decimals to make sure we're not making any mistakes. Okay, so don't freak out. Let's start out the same way we do before, where we're separating our terms with those plus and minus signs. Okay. Now here I see I have x's that are my like terms, and I also see that I just have regular numbers. So with my x's, I have a 2.4x, and then I have a minus 3.6x. So what I'm actually going to do here is I'm going to pull open that calculator, and we're going to use a calculator to help us solve these, just to make sure that we're keeping, first of all, our decimals in line, and then second, that we are keeping our signs correct. All right, so here's our calculator. Now I'm going to be doing 2.4 minus 3.6. So 2.4, whoops, how about I don't forget my decimal. 2.4, and I'm subtracting 3.6. And here I get a negative 1.2. Don't forget my variable, which is x. Whoops. All right, next, let's do our numbers. So I have a 3.1, and I'm adding this to 6. 3.1 plus 6, we can type this into our calculator as well. If you want to do this by hand, you're more than welcome to. Again, I like to use the calculator just to make sure that we are keeping everything correct and our final answer matches what we think it should be. So 3.1 plus 6 gives us 9.1. So again, to write my final answer, all I need to do is write them next to each other. So I have negative 1.2x. This 9.1 is positive, so I'm going to put a plus sign. Okay, again, I'm putting this plus sign here because 9.1 is positive. It's a positive 9.1. This example, I'm going to skip. Okay, so now we're finally getting into these workbook problems. And with your workbook problems, you're going to be seeing a lot of fractions, okay? But remember that 1, we can type them into that calculator, and 2, we should know by now, we should have a better idea of how we're solving these. And we're going to do them the same way, except instead of being able to just add those regular whole numbers easily in our head, we're just going to do that one extra step of typing them into the calculator. Okay, so again, I can separate my terms, and I could see here that my like terms are this d variable, and then I also have these f variables. So let's start out with these d variables here. I have 1/2 d, and then I have a minus 3/4 d. Okay. So one thing I also want to mention is that when you're typing these into your calculator, you want to make sure that you are not typing in the variables. Okay, if you type in the variables, the calculator is not really going to know what's happening. It's going to be a bit confused, and you're probably going to get a weird answer. Remember that when we're combining our like terms, all we're doing is adding or subtracting the numbers. Okay, so here I have 1/2, and I'm going to be subtracting it from 3/4. Now on this calculator, if you look over here, there's an a over b. If I click that, it gives me a fraction. So I can type in a 1, and if I click in the bottom, I can type in a 2. Okay, so there's my 1/2. Now you can see my cursor is blinking right next to my 2. I want to click in front of it like this, so that way it blinks in front in the center of my fraction. That's what I want. Okay, then I'm subtracting, so I'm going to hit my minus. I'm going to come back here, hit my fraction, and I'm going to do 3 over 4. Okay, now you can see here it gives us a decimal, and that's okay, but we should probably keep it as a fraction because we're dealing with fractions. And there's this button next to it, and if I click it, it will convert my decimal to a fraction. So it tells me that when I'm subtracting these two, I should get -1/4. So my final answer here is going to be -1/4, D. Okay, do not forget your variable. All right. Let's do these next two. So 3f and this -2f. I'm going to be subtracting 2f. And again, remember that your sign in front of your term, that's what goes with this. That's how I know I'm subtracting here, because there is a minus sign in front of my 2f. So here I don't have any fractions. I have just regular whole numbers, which is nice because all I need to do is subtract 3 minus 2. 3 minus 2 gives me 1. And I bring my variable f. Okay, now to simplify this a little bit more, I'm going to leave this as just f. Remember before we were talking about anytime you see a 1 attached to a variable, that's the same thing as just having the variable, because 1 times any number is always going to be itself. And then our final step here for our final answer is going to be to write these next to each other. So I have -1/4 D minus f. Okay, so this is going to be my final answer. All right, our next one is multiple choice, and it says which expression is equivalent to this whole long bunch of fractions. Okay, now yes, this is a lot of fractions, but remember, once we identify those like terms, all we need to do is type them into our calculator. Okay, so let's separate our terms with those plus and minus signs. Okay, now I'm seeing a few things I can combine here. I have an A and an A, I have a B and a B, and I have a number and a number. So there's 3 different things I can combine. Let's start with just our A's. Okay, so my first is 4 over 5A. And my second term that I'm subtracting, because there's a minus sign here, is going to be minus 2 over 5A. Okay, so let's bring our calculator to help us. Another way you can type in calculators in this, another way you could type in fractions in this calculator. So if I'm on my number pad now, okay, you can't see it, but I'm on my little 9 pad. So I'm going to hit 4, and then I'm going to do the slash. So you know how there's like the slash button on your keyboard? If you hit the slash button, it'll automatically insert a fraction. And then I'm going to type in 5 for my denominator. My cursor is blinking next to my 5. I need to hit my right arrow button. When I hit my right arrow button, you can see my cursor move in front of my fraction. And then I'm going to be subtracting, and I'm subtracting 2/5. So I'm going to do 2/5, and I'm going to hit enter. Again, it gives it to me as a decimal. That's okay. I'm going to hit this button next to it, and it's going to convert it to me for a fraction, which tells me that it is 2 over 5, and this is A. Okay, so 2 over 5A. So just by solving this one part, I know that B and C are automatically wrong because they have 6 over 5A. And that is not what we get when we simplify them. When we combine them, we should get 2 over 5A. All right, so let's do the next ones, which is 2/3, and this 7 over 6. So I have 2/3 B minus 7 over 6B. And again, I know I'm subtracting because of this minus sign here. That's with my term. Okay, so these ones don't have common denominators, so this is a good time to use our calculator here. So again, 2/3, this is what I'm typing in. I'm going to hit my right arrow button. I'm going to subtract, and I have 7/6. I'm going to convert this to a fraction, and that's going to give me -1/2. Don't forget your variable, which is b. Now from here, I can look. This says that it should be 1/16, and this says -1/2. So that means this one up here, this second term, is wrong. So I know that this one down here is correct, and I don't even need to simplify the third one because I have crossed off the other answers based off of what I know the correct answer should be. Okay, so I don't need to actually do that third set because based off of what we've solved for, I was able to determine our answer. All right, our next one. This one looks a little bit different, and we want to know which expression is equivalent to 0.5x plus 7 minus 1.2x minus 3. Okay. Now, if you remember last semester, this one's going to be a little bit trickier, and it's just because of that minus sign in the middle. Okay. Last semester, we touched on distribution briefly. Okay. Remember, distribution is where you take a number that's outside of your parentheses and you multiply it to everything inside. So when I have this negative sign here with this 1.2x minus 3, this negative sign, technically, it has to be multiplied in. Okay. Now, you might not see a number, but there's going to be an invisible 1. Anytime you have a minus sign in front of your parentheses like you have here, essentially what you're doing is changing the signs on the inside numbers, and it's going to make them opposite. So if I were to have a positive 1.2, let me do this with a different example first. Say I had something like this. Okay. This minus sign here is going to make all of these numbers in here have the opposite sign. Okay, so this 5 was positive, so it's going to now become a -5. This 6 here is negative because this negative sign here, so the opposite of a -6 is going to be a +6. The opposite of a +3 here is going to be a -3. Okay. Anytime you see a negative outside of parentheses like this, that is what that does. So the negative sign outside of your parentheses makes all of the numbers and their signs flip. So they're now opposite of what they used to be. Okay. So when I'm looking at the example that we were given in our problem, okay, I have that negative sign here, which means that everything inside is going to become the opposite. So the opposite of a positive 1.2x is going to be negative 1.2x. Opposite of a -3 is going to be a +3. From here, I want to look and see, well, now I need to combine my like terms, right? So if I look, whoops, I keep hitting the same one. I'm sorry. Here we go. So if I look, I have a 0.5x and I have this -1.2x. Those are like terms. So I want to combine those. And if I look here, these are both positive. Well, that can't be right because this 1.2 has to be negative. Same thing with this one down here. That one has positive, so that can't be it. If I look at A and C, both of them have this -1.2. So this is a good thing. That tells me that those are one of the two options out of those are going to be correct. All right, let's check our last set. And our last set is going to have this +7 and a +3. Well, if I look here, this has a +7 and a -3. That is not correct, which means that this one up here has to be the correct answer. My pen went away. There we go. Sorry. Here we go. Perfect. So again, I have that -1.2, and both of these numbers here are positive. We're almost there, guys. All right. Following The following is a list of bank transactions Gabriel made this month. The variable B represents his initial balance. So it looks like we have a deposit, a withdraw, and a deposit. So this is a little bit different because we have to understand what a deposit and what withdrawals mean in terms of this situation. And we need to think about it as positives and negatives. So think about when you go to the bank, right, and you have a bank account. If you are depositing money into your bank account is getting bigger, right? So if I'm going to deposit money, right, my bank account maybe started at $10. If I am depositing $5, right, my bank account is going to grow to $15. So I now have $15. So when you're depositing money, depositing is going to be a plus, okay, because your bank account is getting larger. When you are withdrawing money, okay, if I'm taking money out of my bank, a withdraw is a negative. Where'd my pen go? Here we go. So withdraw is going to be a negative. Okay, so say I had that $15 in my bank account, but then I needed 10. So if I'm taking out $10, right, minus 10, that's going to leave me with 5 left, right? So depositing is a positive and withdrawing will be a negative. And why we need to know that for this problem here is because we need to take these numbers that they give us with the descriptions that they give us, and then we need to write them in an expression that we can simplify, okay? So I am depositing 125, so this is going to be positive 125. I am withdrawing 1 over 10b, so that's going to look like this, a negative 1 over 10b. I am withdrawing 19, so again, that's going to look like this, a negative 19. And then I'm going to be depositing 1 over 5b, and depositing is going to be positive, so a positive 1 over 5b. Okay, so here I can see I have some like terms. I have those variables and those numbers attached to my b's, and then I also have just my regular numbers. So let's combine those. I have this 125 and this negative 19. So I have 125 minus 19. Again, feel free to type this into your calculator if you would like. When you subtract them, you will get 106. Okay, so that means that these two answers here that have the 144 first are wrong because I know it needs to have a 106. Then let's do the next ones. So this negative 1 over 10b, and I'm adding it to 1 over 5b. Okay, now since I have fractions here, I'm going to type this into my calculator. Okay, so don't forget this negative sign in front of your 1 over 10. So I have a negative. I'm going to do 1/10. I'm going to hit my right arrow on my keyboard to make that cursor go in front. Then I'm going to add 1/5, hit enter. Convert this decimal to a fraction. That gives me 1 over 10. So that tells me that this is going to be a positive 1 over 10b. And if I look here, I can either choose between a negative and a positive. Since this 1 over 10 is positive, I want to pick this one down here. So final answer for the expression that represents the change in Gabriel's bank account is 106 plus 1 over 10b. All right, I believe this is the last question. So here it says we have a length of a rectangle and it's represented by the expression 10.5g minus 3.4k. And the width of the rectangle is represented by 5.7k plus 2.4g. We want to know which of these expressions represents the perimeter of the triangle. And then it says to remember that the perimeter of a triangle is the sum of all 4 sides. So to do this one, I'm going to draw a rectangle. Okay, it tells me that the length of the rectangle is 10.5g minus 3.4k. And it tells me that the width is going to be 5.7k plus 2.4g. Okay, so it tells me two different sides, and I need to add all four sides together. So remember that if this top side of a rectangle is this expression, the bottom side is also going to be the same, because opposite sides of a rectangle have the same lengths and widths, which means this is going to be 5.7k plus 2.4g. Okay. Now this looks like a lot, right? It looks like we're going to have to add together a bunch of stuff, but remember that we have that calculator to help make it a little bit easier. Okay. And if I look at all of my different answer choices, since this is multiple choice, if I look, I can see that G, all these numbers attached to G in my answer choices, right? This one, this one, this one, this one, they all have different coefficients, right? Those numbers in front of our variables, which means that if I add together all of my G's from this diagram here, I'll be able to figure out which one is correct. So that's what we're going to do. We have a 10.5, 2.4, 10.5, and 2.4. So what we're going to do is we're going to add together all of those numbers attached to our G variable. And when we do that, that is going to tell us our final answer. Okay, so I'm going to start at the top and I'm going to move around this way. So I'm going to do 10.5 plus 2.4 plus 10.5 plus 2.4. When I add all of these together, I get 25.8. 0.8g. And if I look at all my different answer choices, this is the only one that has a 25.8, which means that that one is the correct answer. All right, this was definitely a long video, but I wanted to make sure that you guys had plenty of examples before we went into the workbook ones so that you could kind of see what's happening. If you have other questions, please let me know.